Good morning, everyone. Very warm welcome to Digital Catapult. Very good to see so many familiar faces, but also some new faces here. For the benefit of those of you who haven't been here before, let me give you just a few words on what the Digital Catapult is all about. We actually have colleagues here from the Energy Systems Catapult as well. So we are all part of the Catapult programme, which was initiated and is funded by Innovate UK. And acts as an acceleration layer between academia and commercialization. And we, Digital Catapult, are really very focused on the driving early adoption and achieving growth through helping businesses be first movers. As you know, whether you're a startup or a traditional business, if you can be a first mover, that will give you a competitive advantage. It will give you that globally, and that will allow you to grow, attract investment, and take a good piece of global market share, which is what we want everyone to be able to do in UK businesses. However, we also recognise that being an early adopter is very risky. Lots of people are much more comfortable being fast followers than first movers. And so small amounts of public money to help people do that is really what we're all about. And in the digital space, as you know, there are so many fast-moving developments in so many different areas that are transformative in their impact. And in combination with one another, we are seeing extraordinary impacts in industry. In the Digital Catapult, we have really identified 4 or 5 specific digital technology areas where we've grown expertise. So in 5G and in telecoms, in Open RAN, and soon to be 6G, in AI, we'll talk lots about that today, in distributed ledger technology, in immersive technologies, in IoT. We have strong groups of experts here in the organisation who are dedicated to helping work with industry to really see those kind of technologies through into application. As I said, most of these things, as you know, never happen in isolation. They happen in combination with one another. And when we look at the way in which it's most useful to group those and to think about those in terms of the kind of impacts that we can see in industry, and also in terms of the sort of opportunity that UK businesses have got, there are kind of 3 broad areas that we've defined. So one of those is the sort of foundational enabling digital infrastructure, the networks, the data that needs to empower all of the kinds of things we're going to be talking about today. Without those networks, none of this is possible. And we have significant programs in that area, working directly with DCIT, in Open RAN specifically, and Sonic Labs is a £20 million project we're delivering for them in that space. In the next area adjacent to that is more of a kind of design and control environment, if you think about it. And that's really all about virtual environments. So thinking about the ways in which, going forward, we're going to see manufacturing industry both designing products, but also then controlling its systems and its relationships with its end users. The virtual environments, cyber-physical environments are going to become more and more important. And in some places, we talk about that as being about digital twins. In other places, we talk about that as being the metaverse. Well, we talked about the metaverse last year. I think we can still talk about the metaverse. Maybe it's got a small m now, or maybe it's gone plural and it's metaverses. But anyway, there is a space there that I think we can all define, that we all recognize, which is both a place where we can speed up and make design more efficient and reduce emissions in the design process. But it's also clear that a digital twin can become a really powerful control environment as well, in which all of the data and activity can be seen and tracked. So lots of businesses doing that individually at the moment. We are just about to open in Belfast a new national centre for digital twins, which will be a £40 million programme, funded partly by Belfast Regional City Council and the Department for the Economy in Belfast, and partly by Innovate UK, with some major industrial partners, with Thales, Spirit, and some local SMEs, one called Artemis, based in Belfast. And that is a really exciting program. And what that's all about is about both lowering the price of entry to making digital twins, but really importantly, creating interoperability between them and enabling digital twins to talk to each other. And if you want a definition of what we might call the industrial metaverse, maybe that's the place where digital twins talk to each other. Discuss. So the final area that we're very active in, just to give you the full picture of Digital Catapult's activity, is in digital supply chains. So talking lots about enabling and connecting things, but of course that's all within businesses, but very, very importantly, it's how do you put all that together, how do you connect businesses with one another? And we know that supply chains are incredibly vulnerable, both through COVID and the energy crisis. We've seen the kind of frailty of global supply chains, and therefore digitization of those is a really key part of trying to strengthen, make more sustainable and more resilient those sorts of environments. So we're running a digital supply chain innovation hub. We have about 250 companies involved with that. There was 10 million of Innovate money. There's 15 million of private investment from individual companies into that, and that we are seeing really interesting results. Just to give you one example, for example, did you know that 30% of the freight trucks that you see driving around the roads globally are empty? And they're empty because they've been and they've done their business and they haven't been able to connect any other work to go back the other way. Why is that? Well, because the supply chain isn't very transparent, because there's not very much connectivity between one supplier and another. And so using something like distributed ledger technology can allow us to start to create that connectivity whilst retaining commercial sensitivity as well. So really interesting programs that work across the space. And when we look at all of these, the thread that links all of them is the fact that digitization itself is also a green transition, that we know that if we can increase the efficiency and if we can increase the digital effectiveness of businesses, not only do we increase their productivity, but we reduce their waste, and in the process we reduce their carbon emissions and their footprint. And so that thread of sustainability runs right the way across all of those areas of application, and all of those technologies all enable that kind of activity. However, of course, we do also recognize, and I think this is a growing concern, that the more that we use AI, the more energy we're also using in the process. So actually, decarbonisation of AI itself becomes a kind of theme. And it starts to get a bit meta at that point, but on the other hand, no pun intended, but at the same time, I think that we've got to actually try and pursue that. So it's really exciting to see this session and this program getting into gear. The relevance of it coming the week after COP can't really be lost on any of us, and obviously there's a huge amount still to do. I think we're absolutely delighted that we're working with Energy Systems Catapult and our colleagues from Turing Institute, which is based just across the road in the British Library there. So we are a powerful ecosystem, and it's great to be doing that with the help of DESNZ. This is the first real program that we've put together actively with DESNZ, and we hope that there'll be more to come. And of course, linking that with the work we're already doing with colleagues in DCIT as well is doing our bit to join up government, which was always a helpful thing, hopefully. So we're looking forward to doing more. We've got colleagues from the Department of Transport here today as well, and I think it would be great to see where we can go with some of the work we're doing with you guys. And of course, the fact is that the size and scale of this challenge is so huge that we have to actually leverage all of the points of connectivity and all the relationships we can if we're going to address this effectively together. So really interesting set of conversations from people who know far more about this than I do this morning. So I hope we have a really good session together. Great to have you all here. Look forward to meeting some of you in networking afterwards, and enjoy the day. Thank you very much.
So without further ado, I'm going to welcome to the stage Professor Paul Monks, the Chief Scientific Advisor for the Department for Energy, Security and Net Zero. Probably doesn't need an introduction from me, but Paul essentially delivers advice to policymakers and ministers across the department's portfolio, particularly looking at sustainable, resilient and measurable net zero objectives and challenges of delivering national and global decarbonisation. So without further ado, I'd like to welcome Paul to the stage.
Thank you very much. I'll see if I can be as jingoistic as my minister around that. Probably the success, that's rather good. I do have to congratulate you on this project, and nonetheless, actually congratulate you also on what a wonderful acronym. You know, it's absolutely, it's actually one of my top acronyms that I can think of. The best project I ever had was called Godiva. And it was named after the chocolates, not the person in Coventry. Congratulations on winning that. I think, you know, we're actually immensely proud of the UK status as an innovation nation. I used to not like the phrase innovation nation, but actually I think it does really say something about our ambition in this sort of area to innovate when it comes to that. And we want to really push the technological advancements like artificial intelligence. We do want the UK to be one of the greatest places to work and live with AI, ensuring that technological ethics, strong regulatory frameworks and hubs for innovation provide that strong foundation for this seminal emerging technology. AI absolutely remains at the forefront of UK's priorities in science, innovation and technology. In particular, the UK's ambition to be a leader in safe AI systems and their deployment, with principles of applied ethics, transparent laws and regulatory frameworks that encourage innovation. Can I pick up on a theme that Jeremy talked about a little bit? I didn't realise that in 2020, the UK was ranked 3rd globally for private investment in AI firms, only trailing the US and China, and 3rd in the world for AI research and innovation. So I think we've got a real impetus here in the UK, and I think, you know, taking that into the energy and decarbonisation sector is going to be incredibly important. We are putting money behind that. The government, we've all got different numbers. I know Andrew had different numbers. For me, I've got £2.5 billion since 2014, so that's my number for that. We've established 110 million for the AI Tech Missions Fund, 900 million to establish a new AI research resource and develop an exascale computer. That's called Isambard, and it's based in which city? It's called Isambard? Correct. You're good. Audience participation around that. And that actually will be available early next year. But it's not only just about having the hardware and the technology. What's a really important part of it is having the people as well. And we've invested 117 million in existing funding to create hundreds of new PhDs in AI research as well as 500 million over the next 2 years to fund further innovation centres to help make the UK an AI powerhouse. I mean, it's actually been quite a year for AI, and I guess when I often reflect on AI, and I'm here at the Digital Catapult, one of the best views you have in London, I'm often thought that, you know, are we part of the hype cycle? But actually, talking to some of the innovators outside the door here, we've been working on AI for years. You know, it's not something that's particularly new. Yes, ChatGPT, generative AI, but narrow AI is a very powerful tool. We're in a world where we're collecting more and more data. You know, I think it was we collect something like over 1 petabyte every second globally on the planet. So how do you analyze that data? Powerful tools like AI allow us to do that. The energy system has a lot of data in it, and we need to optimize the use of that. And I think AI and machine learning in particular is a good part of that. So it's been a big year for AI. The government set out in its white paper that pro-innovation AI regulation framework, ensuring we've got the right environment for the country to harness the benefits of AI and remain at the forefront of that, of technological developments. We invited some of the world-leading minds to the AI Safety Summit hosted by the Prime Minister in Bletchley to ensure wider international cooperation on responsible AI being harnessed for good. And I think you can already see the outcome of that. You can see the outcome of that globally. Actually, Britain was at the forefront of that, and actually some other countries are now chasing to catch us up, which I think is a really good sign of what is going on. I think also I'd like to remind you that the Department of Science, Innovation and Technology also launched the Manchester Prize. If you're not aware of the Manchester Prize, I think it's a really, really good thing. So we'll award £1 million every year to a team of innovators with the most cutting-edge AI solution for public good, with the first prize being awarded to innovative and impactful AI solutions, which demonstrate social benefit by overcoming challenges in the fields of energy, environment, and infrastructure. So two out of three there for us. So you know, I think it's really good, and I'm really pleased with that sort of initiative, because I think actually using the ingenuity of our technologists, the ingenuity of our people, and actually rewarding that, prizes are a wonderful way of doing that. So if you haven't looked at the Manchester Prize and you're an innovative company, if you've got an innovative idea, go out and apply for that as well. We know that AI has the potential to enable greater productivity and efficiency in decarbonising the energy system and the economy more widely, with studies showing how AI technologies can increase the pace of decarbonisation, making it a critical technology to enable significant emissions by 2030. And I often say, you know, the simplest form of emission is the energy that you never create. And in some senses, I think AI allows us to do that. I think Jeremy laid out a little bit the challenge about digital decarbonisation that goes along with that. So we've got to do that full accounting around this. Let's not just move carbon around the system, please, as part of that. I think the UK AI Council itself also acknowledged this and outlined that the government should embed achieving net zero with the development and implementation of AI, and highlight that AI is a crucial tool in the toolbox for climate innovation. There's a fascinating stuff going on with AI prediction of climate, and AI prediction of weather as well, and how those systems can actually learn. And the question is, how do they actually handle that information, control that information? I think is a fascinating area of that. And we're very interested in how AI can help us with climate and climate solutions in particular as a part of that. One of the recommendations for the AI Council was to absolutely build on the existing success of the Alex Turing Institute as a national champion for AI research, development and innovation in the UK, which we certainly hear today with the establishment of ADViCE in a partnership between Institute, Digital Catapult and the Energy Systems Catapult. Really, for me, that centre that aims to bring together stakeholders from various sectors and foster that collaboration on the use of AI technologies for energy and decarbonised applications is absolutely essential. And that centre will also hopefully identify innovation opportunities in the AI decarbonisation applications, including areas where the UK can have the most impact. Can we use it to really deliver energy and net zero in a cost-effective manner? So do we have those algorithms for success? I think that's a really good challenge for our minister on that. Look, I'm really looking forward to hearing what's going to go on today. I'm going to stay around this morning as part of Sarah and I, for my fellow CSA, on a bit of a CPD morning this morning, because we actually want to learn more about this sort of sector. What I want to learn is, what is the art of the possible? Where is the top of the hype curve? What should I believe and what shouldn't I believe? So hopefully I'm going to get the advice that I need to be a chief scientist in the system from you this morning. I really look forward to hearing your exciting work and wish you all success for the coming months. Thank you very much indeed.
Thank you so much, Paul. Yeah, if it's not already clear, this is why it's so important to have a mixture of AI innovators in the room, industry players looking to adopt AI, investors, academics, researchers. This is all part of bringing everyone together to solve some of these sort of challenges as they emerge. And we'll be talking a little bit more about the challenges with my colleague Sam in a bit. But now we're going to get back to the ADViCE project specifically and give you more information about what we're up to. And my colleague, Dr. David Pugh, who I mentioned is our Director for Sustainable Industry, is going to give us a bit of a run through the current context and a bit more about the ADViCE project. So over to you, David.
Good morning, everyone. It's great to see so many people here and online as well. Thank you for your time this morning. So I wanted to take this opportunity this morning to speak to you a bit about where we are in sustainability in 2023, what's happened over the last few weeks, and where ADViCE is going to play a key role in taking us forward. So sustainability in 2023, this information comes from a report from Deloitte interviewing more than 10,000 CXO level staff at various organizations across Europe, who are saying that they are increasingly feeling the pressure from not just consumers, but their own boards, their employees, to take action on climate change. This isn't just a case now of we should do sustainability work, we should address climate change because it's the right thing to do. We don't have a choice, we are being told to. Despite a whole host of different pressures in 2023, cost of living crisis, energy crisis, XYZ crisis, sustainability remains at the top of people's priority lists. And you can see there, 61% of CXOs said that their sustainability is having a high impact on their strategy, on their increasing sustainability investment, and they're extremely optimistic about the future. And I'm going to take a few kind of reasons to be cheerful from the UK this year, and things that we've seen at a high level. So one piece of good news is that 17,000 residential solar panels have been installed every month since January. That's not just screwing them onto a roof, that's getting the grid connection, that's getting them connected into the grid, that's becoming part of the energy system. And that's residential. So that's not just businesses making a commitment, that's people saying, yes, I can be part of this journey. Equally, we've seen EV sales go way ahead of their predictions. So 1 in 5 new cars sold globally is an electric vehicle today. Now, I was in Detroit many years ago at a motor event just after Donald Trump had removed the US from the Paris Accords. And on the stage was CEO after CEO from a big motor company. And the question was, well, we don't have to do this anymore, should we? And every CEO said, we don't have a choice. The market will decide, it has already decided. And this is evidence of that we're seeing more and more electric cars. There's obviously challenges that come with that. We need to make sure we have enough grid connections. We need to make sure we have enough charging points. But the market is moving towards more sustainable options. And speaking of electric batteries, the UK is becoming a huge battery hub. This year, we've seen a big announcement for a big gigafactory in Sunderland that's going to be producing electric vehicle batteries. This is a picture of what will eventually become Europe's biggest battery. Very different from a AA that we're used to seeing. But this is at the Wilton site in Redcar, big chemical plant, and they're going to be producing about 360 gigawatts of energy through this battery. So there's lots of reasons to be cheerful, lots of reasons to see that we are moving forward. Gigawatt hours, sorry, my mistake. It would be foolish of me to try and ignore COP. I'm sure we've all seen the headlines. We've all seen lots of news coverage about how COP isn't moving as fast as we'd like it to. And I think every year we could sum up COP as we move somewhere, but we'd like to move faster. But when you're trying to get every country in the world to agree on anything, it's a difficult challenge. I tried to get my parents to agree on what they went for dinner last night, and that was 90 minutes. That's just 2 people. There's lots of reasons to see good science data. 200 countries have aligned on language to transition away from fossil fuels. This is the first time that's been possible. More than 100 countries have been pushing for text to say phase out fossil fuels. Now, this is progress. Sometimes it doesn't feel like it. Sometimes we feel like we should be moving a lot faster, but this is the world that COP is. Another key thing, and I'm sure you've all read through the agreement last night as I did, but the word acceleration features incredibly heavily. There are literally hundreds of references. Here's just 8, but you can see we're accelerating efforts towards phasing down coal power. We're accelerating efforts towards net zero products and services. We're accelerating. And that's the really key point that I think we need to take away from COP this year, is that there is a real commitment to accelerating the work that's going on. Beyond just commitments, because this is just a document, there's lots of things that the sustainability movement still needs. We need courageous leadership. We need ambition and advocacy that serves a viable future rather than self-interest. And we need a commitment to action now, not just the ability to hide behind a commitment that leads us to 2050. And it's that radical collaboration that ADViCE is really at the core of ADViCE. And it's moving past kind of current tunnel vision around incremental innovation towards actually design and system changes utilizing AI. And so the real work really starts now. There's a key reason for that. Under the Paris Agreement, the UK is committed to a 68% reduction of emissions compared to 1990 levels. By the end of this decade, we're currently around 48%. Now, a lot of the low-hanging fruit has already been tackled in addressing that 48%. And so it's that 20% where we really need to start accelerating. There are a lot of challenges, but also a lot of opportunities for the next 6 years, and AI plays a key role in all of them. So these challenges are vast, but they are very data-driven. We're looking at flexibility in our energy systems. We're looking at reducing the embodied emissions from our materials. We're looking at our land use. We're looking at enabling sustainable supply chains. These are all very complex challenges. They're going to be really interesting to solve, and data plays a key role in all of them. And this is where ADViCE comes in. So ADViCE exists, as you've heard this morning, to bring together an ecosystem of AI companies, of innovators really at the cutting edge of AI, industrial adopters, the people that may not necessarily understand AI today, but they're going to need to know how to use these things if they want to stay ahead. Policymakers are really crucial in driving these forward, and investors to support, promote, and coordinate the adoption of AI technologies. And we'll be focusing our efforts into 4 industrial sectors. And these sectors are agriculture. So land use is our current biggest emitting sector, about 25% of UK emissions. The built environment has huge challenges around embodied carbon going into buildings, going into railways, going into all sorts of areas in the built environment. The energy sector is already going under huge changes. And we'll see more and more of that as we move to distributed system operators and then the future system operators as well, and manufacturing. So again, a very core industry to the UK that creates 23% of the UK's emissions. So key sectors that are really crucial for both adoption of AI and supporting decarbonisation. Now, success of AI will drive a lot of different things. It will drive new connections and collaborations between all of these groups. It will bring increased considerations to using AI responsibly and ethically. So we've seen lots about the dangers of AI, but there's lots of things we can do now to make sure that that is used in the right way. It will increase the costs of delivering net zero by looking at economies of scale, and finding new ways to get there. A whole host of other serious impacts are going to move us to net zero faster, move the AI system and what is a brilliant AI system in the UK towards supporting those net zero goals. Now, ADViCE is being delivered by three really important parts of the UK innovation system. If there was an Avengers film of decarbonisation, these would be the main characters. We have the energy systems Catapult, who are accelerating the UK's transition to net zero through supporting innovators and helping to deliver that future energy system. The Alan Turing Institute, the UK's National Institute for Data Science and AI, representing our brilliant academic sector, and Digital Catapult, the UK authority on advanced digital technologies. Now, all three of these organisations have data, AI, and sustainability all at their heart, and they're going to be really key. And so, not just these companies, but the ecosystems that they represent are going to really bring together a really quick and positive transition towards net zero. Now, the success of ADViCE is only really going to be possible with collaboration and enthusiasm and participation from everyone. So this is how you can get involved next year. Now, there'll be opportunities you'll see later in the presentations. There are some QR codes to get involved, but you can see we've got 4 key activities next year. Firstly, data science sharing circles. These will be led by the Energy Systems Catapult. And if you are a technical developer working on various aspects of decarbonisation, these sharing circles are bringing together these groups to really tackle AI challenges, peer-to-peer learning in a safe sustainability space. We'll be hosting a series of industrial working groups supporting adopters of AI technologies and understanding what the key things that need to happen. How do we share best practice? How do we learn from each other? We have a webinar series and engagement series looking at various aspects of decarbonisation with key stakeholders from all of the different industrial sectors, as well as key innovators showing how the art of the possible and how AI is playing a key role. And finally, we'll be having study groups led by the Alan Turing Institute, where if you do have a specific decarbonisation challenge, there'll be groups of academics keen to work with you and help you solve those challenges. That's all from me. I'll hand back to Vicky and Sam, who are going to talk us through challenges and some of the things that we've learned over the last year of ADViCE.
Brilliant. Thank you so much, David. So I will invite Sam up to talk about our second report, but hopefully that sort of set the framework of the ADViCE project and the things that we're looking to achieve. We've been running now for a couple of months. And during those couple of months, we've been very excited and we've been working hard to deliver 2 new reports, looking at the AI for decarbonisation landscape, as well as the sort of current challenges that we foresee will sort of drive and accelerate innovation in this space. So I'm going to be covering the landscape report, and Sam will talk a little bit more about the challenges to follow. So you can see the code on the screen to download today's report. This is launched as part of the event today, so please feel free to scan and download, and we'll also be sharing links to them after the event as well. But yeah, just to kick off, I'd really like to sort of share some high-level findings from the report assessing the UK landscape for AI and its use in decarbonisation. So this report, essentially for us, provides a launch pad for the rest of the project. It's very much a sort of current snapshot of the UK, from the policy landscape across AI and climate ambitions, AI for decarbonisation, innovation and adoption, as well as exploring current use cases and bodies in the ecosystem. The aim of the report is to set the foundations for further work and innovation in this space, identifying gaps and market opportunities that will form the basis of the rest of the ADViCE project. We also, I will talk a little bit through these in a bit more detail, but we deliver a set of cross-cutting recommendations at this initial phase to look at further avenues for investment and growth. So we've conducted this through a range of primary and secondary research and have undertaken some initial engagement with some really key innovators in this space. So as you can see, looking at the ecosystem at large, at a high level, there are around 330 plus companies that are actively defining themselves as working across AI and sustainability, working with industry to respond to key sustainability challenges using artificial intelligence. And whilst the space has grown, we can see already that 75% of the companies defining themselves as such are based in the London and wider southeast. And largely these companies are seed stage companies. So a big consideration going forward is how we enable that growth and scaling opportunity and also extending more opportunities across the UK. And when it comes to use cases, whilst there's a range of tools being developed, and we'll hear from some of the companies today, and we'll have some people at stalls talking about all the tools, exciting tools and range of them that are available, it's still clear that data plays a significant part. And we're looking at different things like data analytics and insights platforms that are basically there to sort of drive better decision making across industries. And whilst this is great and these areas are growing, we really want to sort of explore further tools, innovation, and also really sort of focus on that specific decarbonisation impact as opposed to just optimisation and cost efficiency. So just to give a very sort of broad overview of what the report covers, it kicks off with an overview of the sort of UK policy landscape that feeds across this space. So the UK, both in tangent, has set ambitions to not only become the best place to live and work with AI, with ethical principles and a pro-innovation regulatory environment, but also to deliver an industrial renaissance where the whole of society can work together to reduce emissions. So some of these things we've kind of brought together to see how they can work in tandem. And we've also put this in sort of a global context to explore what other countries are doing when it comes to AI for decarbonisation. We then sort of kick off and look more at sort of the key AI tools and use cases for decarbonisation that kind of bring these policy ambitions together. So whilst AI adoption for decarbonisation is quite a difficult thing to track, so we've looked at AI adoption and what it's looking like across the sectors and scope for the ADViCE project. So that's agriculture, energy, manufacturing and the built environment. And whilst it's clear that sustainability across these sectors is a core ambition, there are fewer cases, as I've mentioned, where the immediate impact of using AI is focused specifically on decarbonisation. So we then go on to the second line, where we have had a quick delve into and set a snapshot sort of picture that we'll hope to continue to grow as we engage with more people across the ecosystem during the project. But we look at the sort of existing funded research centres of excellence through to the investor landscape, existing programmes. There's a range of AI and decarbonisation programmes. So we'll really look to sort of see how ADViCE can intersect and work in collaboration with them, make sure that all the innovation portfolio is working together and collaborating together. So as I've mentioned, this report really does set the foundation for the rest of the ADViCE project, raising existing work in this area, but also understanding the key challenges further. So based on this sort of initial research, I just wanted to spend some time this morning talking about some of the recommendations that have come off the back of this initial report. But as I've mentioned, the real focus is driving and boosting the diversification of AI tools being developed and increasing adoption routes to industry. So the first recommendation that we set out is cross-sector collaboration and knowledge sharing. We spoke to a range of companies and it was really clear that some of the success of the AI tools being developed for these sectors really came when there was heads coming together from the sector knowledge, understanding the challenges of a specific sector, having the AI skills to know how to respond to that challenge, and then also working with academics and researchers to really sort of come together and understand how all those things can work together in tandem to deliver diversification and decarbonisation. We also spoke to companies about collaborative and investment opportunities. As I've mentioned, a lot of the companies that are working in this space are seed stage. So further investment is kind of critical, not only to driving more tools, more innovation in this space, but also enabling companies to work beyond one single sector and look at a range of sectors at the same time. So focus on decarbonisation impact. It's clear that data-ready businesses are already set for AI adoption. This is largely, as I've mentioned, focused at the moment on efficiency and reducing costs. But to accelerate decarbonisation through the use of AI, we need to consider further decarbonisation challenge-led opportunities specifically. So really looking at that decarbonisation piece in more detail. And where funding is being sort of given out to AI innovation, we really foresee that a good phase could be to include decarbonisation impact as part of the sort of criteria for some of the funding, or at least sort of build that into some of the programmes that are doing this work already. And this would be essentially to help the reduction of emissions, but also to address blockers to decarbonisation. Responsible adoption and building trust. So number 3, we're all aware of the risks AI poses, and I think the consortium that we've got on board for this project, Digital Catapult, Energy Systems Catapult, and the Alan Turing Institute, responsible adoption, particularly of AI at this moment where we're all grappling with what it's capable of, is really critical. So we really want to sort of see a focus on de-risking decarbonisation innovation when it comes to AI, and as well as sort of thinking about data accessibility and trust. Building trust in AI systems is a really important thing, and we all sort of need to come together to raise that trust so that people can really sort of see the benefits. And as AI systems continue to evolve, we need to ensure that safety and security evolve with them. And this is part of a range of programmes that Digital Catapult, I can speak on behalf of, are already involved in. We've been working with the Department for Science, Innovation and Technology, as Jeremy mentioned, on cyber-physical infrastructure. And this is really all about building trust, enabling data interoperability, and really sort of bringing an ecosystem together to drive innovation that is safe and secure. Enabling skills pipelines and place-based opportunities. So it's clear that corporate agility is a real need when we're looking at AI adoption. New skill sets emerge as new tools emerge, and this can often replace legacy approaches and skill sets. This particularly is sort of important when it comes to infrastructure and making sure that we can sort of build around what already exists and also make sure that the workforce is skilled. So we recommend that the government continue to work with industry to develop a range of skills leadership initiatives, particularly related to AI for decarbonisation, and really support businesses with how to overcome technical barriers and being data ready. And this can align with existing AI adoption and skills programs. So one of the ones that Jeremy, I believe, mentioned this morning is the Bridge AI programme, kindly funded by Innovate UK. It's a big investment that's all focused on AI adoptions and skills in a responsible manner. And so we foresee that ADViCE can sort of really work with programmes like that big investment to drive that decarbonisation focus as well. And when it comes to place-based opportunities, as I've already mentioned, it's really critical that the adoption of AI into companies and sectors that underpin economies outside London and the South East, it's so important. And this programme really we're looking to engage with regional people innovating in this space, but also what needs to happen is leveraging existing cluster strengths around the UK. We can see local decarbonisation plans being developed, but all of these things don't necessarily lead to AI adoption. So bringing those two things together, there's all this regional work happening when it comes to decarbonisation. How do we bring AI into that as well? And finally, cross-technology decarbonisation exploration. When we were doing the research for this report and speaking to some companies, it's really clear that AI is only one piece in a much bigger puzzle of various technologies. This includes sort of big data, the Internet of Things, cyber-physical infrastructure like digital twins, and there's a lot of innovation happening in decarbonisation that includes AI as part of a bigger stack. So connecting ADViCE directly to things like the cyber-physical infrastructure work will be a really good starting point when it comes to aligning policy goals across government departments and new initiatives as they continue to emerge, not just for AI, but other technologies as well. So where does all this put us? We're very much at the beginning of ADViCE's journey, and as we continue to convene key players across the national ecosystem, from industry through to AI developers, local national government, regulators and researchers, the event is really the sort of start of this. So the next phase of the project will essentially be to continue to bring communities together to share knowledge, best practice, building bridges to establish common goals and frameworks that will drive UK leadership in this arena. We will find the algorithm for success. So we urge you to get involved. There's a code on the screen. We will, as I say, continue to share these codes with you and post-event as well. But if, as I've mentioned before, if you're an investor who wants exposure to new companies that are doing some really exciting work in this space, if you're a company that wants to adopt AI but isn't sure how to improve your decarbonisation objectives, or an AI company looking to solve critical decarbonisation challenges, please register your interest in the programme, and we will be in touch and look forward to working with you going forwards. But on the topic of challenges, I'm now going to hand over to Sam Young from Energy Systems Catapult, who will talk a little bit more about the second report that's running in conjunction with this one, focused on all the decarbonisation challenges you need. And you've got them on cards as well, so that's exciting. Over to you, Sam.
Thanks, Vicky. If you are here to solve decarbonisation challenges with AI, which I think is why you're here, it's really important to avoid the efficiency trap. AI does get applied in a lot of these sectors, but so often it's applied to improving efficiency of BAU processes and reducing costs. And that's obvious because it's easy to build a business case. But often that's not where the real blocker to decarbonisation is. Let me give you an example. The first AI project in the wild that I worked on was using computer vision to assess the condition of overhead lines so that you can improve how they are maintained. And the challenge with that, technical, you can do it. We managed to do it. But all that does is reduce the maintenance costs of the existing network. The real challenge for decarbonisation is not maintenance costs on the existing network. It's the fact we have to build hundreds of billions of pounds of new infrastructure very quickly to decarbonise our energy system. And so that's what we've been looking at, is thinking about, well, what are the categories of AI for decarbonisation that are important? There's the obvious AI applications that maybe don't really have much decarbonisation impact. There's the ones that are really clearly aligned with decarbonisation, so optimising wind farm design. And then there's the systemic blockers that might not be so obvious, that we can see, well, AI might not be the answer, but how can it play a role in solving some of those challenges? So we've been looking at that and have come up with 9 grand challenges for AI for decarbonisation, which I'm going to talk you through. The first is unlocking domestic decarbonisation. If we're going to decarbonise heating in homes in the UK, then practically every home needs a change of heating system and changes to consumer behaviour. And achieving that, getting consumer buy-in, financing it, delivering it at pace and at scale, all of that is an incredible challenge. The second is enabling net zero infrastructure. So as I said, we need to build a lot of infrastructure of various different forms to decarbonise our society. And doing that at pace and at scale is a real challenge. We see connections for renewables to the grid. The pace of those connections is currently slowing down access to renewables. The third is maximising flexibility in energy networks. So if we are shifting to a high renewables energy system, we need to also start to shift our demand to times when the wind is blowing and the sun is shining. And that requires changes to technology, networks, behaviours, business models. There's a lot of change required to achieve that. In manufacturing, a lot of manufacturing processes have high carbon inputs. And the challenge is not just improving efficiency of the processes, but actually decarbonising those inputs themselves. And that is really a key challenge for manufacturing. In some cases, it's going to be very difficult to decarbonise those inputs. It's going to be difficult to decarbonise them quickly. And in that case, improving the manufacturing process efficiency can play a key role in decarbonising manufacturing. In agriculture, soil is one of the key sources of carbon emissions in the sector, but also offers the opportunity for negative emissions with carbon sequestration. And optimising soil management from an emissions perspective is a key challenge. And then finally, minimizing methane in agriculture. Methane emissions from livestock in particular are a major source of emissions, and minimizing those whether through helping people transition to low carbon diets or optimizing the kind of current livestock management with an emissions focus is another key challenge. But what we find with lots of innovators is they're broadly aware of these at a high level, and they kind of see those. Probably for you, those aren't particularly new. The challenge really is getting down into the level of detail below that. And if you're an innovator in energy, maybe you understand the energy challenges, but you don't see the opportunities in agriculture. And so that's what our challenge report has been focused on, is trying to get into the detail of some of these. So we have a 30-page technical appendix, which you're welcome to read, but we also have some challenge cards, both physical versions on your chairs and online versions for you to look through, which go through sector by sector some of the decarbonisation challenges in more detail and sort of how AI might be able to help with those. So either assess those challenges based on their decarbonisation impact, the suitability for AI, and how novel it is to apply AI to that challenge. And we know that these aren't the complete exhaustive list. This is the kind of us starting the ball rolling on this. And we're hoping that as the community comes together, we'll build more and more of these challenges and people can gain that insight and spot the opportunities. What I want to talk about to help you imagine some of that spotting a systemic opportunity is AI for heat pumps. So heat pumps play a critical role in decarbonising domestic heating in the UK, but we're comparatively slow to adopt them. So if I say AI for heat pumps, what's your first thought? How do you think we should apply AI for heat pumps? Most people's first thought is control. Let's apply AI to optimize the control of the heat pumps and make them more efficient. But that's not really the challenge. The real challenge is adoption. And so the question, when you think from a systems perspective, is, well, how could we use AI to accelerate the adoption of heat pumps? Let me take you through just a high-level example of some of that. One of the big challenges with adoption is negative perceptions of heat pumps. Installers don't tend to think of them positively. They think of them as unproven, unreliable, expensive. And if the heating installer thinks that, you can bet the consumer does too. If the person who comes around to your house to look at your heating system says, "Nah, don't get a heat pump," you're not going to get a heat pump. Well, why do installers think that? Well, part of it is that heat pump systems and installations are a bit harder to design typically than boilers. And what that means is it's more complex and time consuming. You need to actually design the heating system as a whole rather than drop in a new boiler. But also that means that there's a general lack of skills because lots of these heating installers haven't been focused on designing the whole system. They've been, well, I'll drop a boiler in. And of course, if you're an experienced heating installer, you're not going to say, oh, well, the problem is I don't know how to develop a heating system. You're going to say, oh, no, heat pumps, they're not great. The lack of skills has other problems as well. If you have negative perceptions of heat pumps, that's going to stop people retraining and kind of investing in reskilling for heat pump installation. But it also means that the installations that do happen may end up being of more variable quality, lower, kind of feeding back into that loop of negative perceptions. And then, of course, you have the upfront cost, and that itself is also a factor that influences negative perceptions. So we're in this place where there's several different negative feedback loops which are slowing down adoption of heat pumps in domestic heating in the UK. How can AI help? Well, let's think, optimizing the operation of a heat pump. Is that going to help some of these? Well, maybe a little bit, but it's not really directly targeting the factors that are affecting it. What we really need to be asking ourselves is, well, how could we use AI to help make designing heat pump and heating systems easier? How could we lower the skills barrier to make it easier for people to design them, make it less likely for them to get it wrong? How could we use AI to accelerate the process of designing and installing heat pump systems? How can we use AI to help detect when there are installation problems and help identify how to resolve those. That's the real challenge, is how can we address some of these systemic issues? And if we do, then we have to apply other factors. It's not just AI is the golden solution here. But if we start to change some of these, then we can shift from a case where we have these negative feedback loops slowing down adoption to the place where actually there is this continual feedback loop of competition functioning as it should and cost and quality pressures continually improving, and that accelerating the adoption of these low carbon technologies and they being more attractive to consumers because they are the cheapest, they are the best. And that's what we should be aiming for. So the question that I want to leave you with here today is, if you are in industry, are the challenges that you have for decarbonisation getting to the innovators? Are you making sure that you're talking about those decarbonisation challenges, talking about not just cost, but also decarbonisation? And if you need help with that, that's part of what ADViCE is here for. Come share your challenges with us, talk to us, and we can help connect you with innovators in the space. If you're an AI developer or funder, look at what you're developing. Is it really going to drive decarbonisation impact? Or is it at risk of falling into that cost efficiency trap? Look at the challenges that we've got. Use those as a spur to kind of challenge yourself. Am I really focused on things that are going to drive that change and that impact? Thank you very much. Back to you.
Thank you, Sam. So yeah, really hoping that that has given you some good food for thought. This really is all focused on critical decarbonisation challenges. And as we mentioned, this is a convening the ecosystem. If you have those challenges and you want to share them, please do. There'll be links at the end to get in touch with a little bit more, but we're going to find out a bit more about what's happening on the ground and some of the challenges from some fantastic panelists. So I'm going to hand over to Professor Adam Sobey from the Alan Turing Institute, who will be chairing a panel today with the following fantastic people. So we've got Professor Chris Baker from Rodhamsted Research, Peter Dudfield from Open Climate Fix, Buffy Price from Carbon Ray, and Dr. Rebecca Ward from the Alan Turing Institute. So if you can join me in welcoming them to the stage.
Thanks very much. I see people to the left of the road, but I'll kind of try and peer over and we'll see my side and see the faces. But thanks very much for inviting us to have a panel conversation. I think we've got some very panelists today across different sectors who can talk a little bit about the journey that they've had with AI. It's a difficult journey according to most studies. I think the world is saying 85% of AI projects fail to final implementation. And so we're definitely seeing a lot of excitement and a lot of difficulties. So I'm Adam Sobey. I'm the Program Director for Data Centric Engineering at the Alan Turing Institute, and also Professor of Data Centric Engineering at the University of Southampton, where I sit in the Maritime Engineering Group. I'm a non-executive director of two companies. One, Thea, who develop meta-ocean data and voyage optimization software for the maritime industry, focused around decarbonisation, and also a company called ADViCE, who I think are the first people to have done assurance of this with the maritime industry, so some experience of actual practical things rather than just academics. Our mission in data centric engineering is around the adoption and development of tools, data science, machine learning, and artificial intelligence, and then the application of those within the engineering community. So solving some of the problems we have around these tools for specific for engineering context, and then supporting companies on that innovation journey from journal papers across Instagram. So each of the panelists introduce themselves, and I'm happy that they can also give an example from their experiences of where AI is sort of supporting decarbonisation.
Thank you kindly. Okay. So my name is Chris Baker. I'm with Rothamsted Research. I'm a science director of the Directorate Intelligent Data Ecosystems. So this is a group across the Institute that supports and underpins 350 scientists researching in agriculture. So Rothamsted is the world's oldest agricultural research institution and has been involved in generating data for over 150 years. If you've ever done an F-test in your statistics class at the undergrad or done ANOVA, these were invented at Rothamsted. So not only do we have the agriculture that's been going a long time, we've been innovating in data and statistics for a very long time. Currently, we are engaged in a wide range of projects involving AI. Most recently, we've been developing digital twins of experimental farms in Devon in the southwest. This is quite an exciting project, also co-funded with the Alan Turing Institute. And we've also received a new investment of 4 million to build high-performance computing infrastructure specifically for ag data science. So I think I'm going to stop here, but that's kind of our credentials for the time being.
Thank you. Hey, everyone, can you hear me? Excellent. I feel like I got married recently, so I'm having flashbacks to my wedding speech. My name's Peter Dudfield. I've missed out my doctor on there, but oh well. I'm head of technology at Open Climate Fix. My background is renewable energy. I worked at Siemens Wind Power for a bit out in Denmark. Came back to the UK and worked for Habitat Energy, where we were optimizing big batteries. We saw a picture earlier of one of those. Open Climate Fix, we're a not-for-profit. We're mainly been focusing on solar forecasting and working with National Grid for that. I will give an example. What was it? Something to do with how AI supports decarbonization. Yeah, so maybe with the solar forecasting, we've been using some AI, kind of big machine learning models, using satellite, using weather predictions to improve the forecasts of solar in the UK. I'll leave it at that. Thank you.
Okay, hello, good morning. My name is Buffy. I'm co-founder and interim CEO of Carbon Re. We're a spin-out of UCL and Cambridge University, focused on industrial decarbonisation. We fit firmly in Grand Challenge 5, focusing on process optimisation. We are developing solutions to reduce the amount of fossil fuels or alternative fuels being burnt in the high heat process of materials production. We're focusing on cement as our first prototype. So we are applying AI in everything we do. Certainly how our solution fits into the bigger ecosystem. I think Victoria mentioned earlier, there are solutions that are out there. There's CCUS is a key example of something that's going to be essential for decarbonisation. Working? I don't think I'm. But there are a lot of avoidable emissions that can be solved through solutions like ours that can certainly find the optimal use and the optimal process for materials production. I think I'll stop there.
Hoping you can hear me because I have been mic'd up, so I'm not sure if it's working, but so I'm Rebecca Ward. I'm a Turing Research Fellow at the Turing Institute, I suppose, and I'm making some instructions. Oh, is that what you wanted me to do? Oh, yeah, okay, that's better. Okay, thank you. Yes, so I'm a research fellow. My background is in building energy analysis, so I'm really interested in analysing and reducing building energy demand, and specifically in the impact of occupants on the buildings, and operational electricity consumption is kind of my field. Over the recent years, I've got very involved in looking at the physics of plants in buildings, so looking at the cooling impact of plants. So that involves working with glass houses, greenhouses, and latterly with an underground farm.
So the project that I've been involved with over the past couple of years at the Alan Turing Institute, it has another great acronym, which is CROP, the Crop Research Observation Platform. I'm very happy with that one. And that is effectively, it's a digital twin platform that was designed to help the growers in the farm minimize their electricity consumption while still fulfilling all their orders and growing their crops to the time scale needed. So I'll leave it there. Thank you.
Cool, thanks everyone. So I guess we'll lead off with our first question and see where we get to. So I guess one of the main problems people are having with AI is picking the right time and place to use it. There's people who say you should never use AI, and there are people who are saying AI solve all problems. I think we're probably in a place where we're in the middle of that. So perhaps an example from each of you where you can see a blocker for decarbonisation if AI didn't exist, and sort of how AI helps you, or data science, machine learning helps you get past that blocker to decarbonisation would be great.
Okay, I'll jump in here. So decarbonisation on the farm. So greenhouse gas emissions, I mean, I believe agriculture is the 48% of emissions from in the UK of methane come out of agriculture. The challenges around this obviously are manifold. The key is that this hangs between the type of feed that's provided, the rumen microbiology, and then obviously the amount of gases that are emitted. And this sort of combination needs to be optimized. Now, to properly understand this, we actually need to look inside the rumen, understand the metagenome, and to do that, we need to sequence the whole metagenome and assemble all these reads to properly understand what is actually the best or lowest contributing metagenome that for greenhouse gas emissions. So this is just one example where advanced AI for metagenomics, right, is going to help us on the farm to decarbonize.
Yep. I'll try and give two examples. The amount of wind generation is going to triple over the next 10 years. Amount of solar generation is going to times by 5 in the UK over the next 10 years. This is just changing the energy landscape how it is. Forecasting is just going to be hugely important. AI is kind of unblocking this. Another example we've seen is on the optimization. Essentially, from the national energies level right down to smart homes, AI is going to be important there. Various different solutions.
Hi, so the thesis that underpins our approach was led by my co-founder, Dr. Daniel Somervell, who did his PhD at the Institute for Manufacturing at Cambridge. And he was looking at cement production and looking at historical data, and could see that there was a difference of about 20% on a good day versus a bad day at the amount of fossil fuels that you're burning in the cement production process, whilst maintaining the same quality. So we know that these plants can operate 20% better in their existing infrastructure without any hardware changes. This is something they're able to achieve today. But they are working on a reactive process. So the high heat process, we're talking about sort of 1500 degrees Celsius in a continuous process. Your clinker needs to come out of that process to cool down, go down to the lab. We can looking at like up to a 4-hour delay of understanding the quality of the sample that's been coming out of the process. So what we're able to do with AI is feed into a distributed control system, build a digital twin of the live environment of what's going on in that space, and find the optimal set points to reduce the amount of fossil fuels you're burning whilst maintaining that quality. So what we're able to do is move that from a reactive process to a predictive process. At the moment, we're reducing the amount of fossil fuels by about 1 to 2%. We've got a clear pathway to deliver that, increase that up to 8%. And there are some research areas that we think we can really push that envelope up to sort of 15 to 20% by optimizing and increasing the amount of alternative fuels, for example.
Or maybe I should use, oh no, there we go, brilliant. Okay, yeah, actually slightly different. Sam's already touched on the first challenge there, which is getting heat pumps into residential homes. And actually, I think that the problem is bigger than that, in that if you look at an individual home, yeah, sure, your heat pump might be your solution. But if you put that home in its context in the street of houses, then actually you might be better off with a district heating solution for that street. And then if you put that district, that street into a city, then what's the best solution across the city scale? So you're looking at the problem, or you need to look at the problem from different scales. And that's an incredibly complex problem. And the only way of solving that is by gathering one way, gathering lots and lots of data and using AI, using machine learning to actually come up with an optimized solution across the different differences of scale and different problems that you can be analyzing. So there you go.
Cool. I think they're really great examples. Like, there's just so much going on across different sectors. So just for audience, we've got about another 15 minutes where I'm going to ask some stock questions that the panelists have been able to prepare a little bit so that they can feel comfortable. But then we're going to open it up to you to ask anything that you feel like. So please spend about the next bit thinking around some of these the answers that the panelists are giving, or just any of the things that you want to voice here today. It'd be really good. I guess the next thing we want to think a little bit about as well, I think, is regulation. I think some people are really seeing this as a blocker to innovation. I personally think regulation supports us in that. A good example is I'm helping the US Navy develop an autonomous vessel that's going to operate in the Pacific for the next 6 months from later next year. There's no real regulation around that. So who's responsible if it crashes? That's a little bit worrying. So I'd quite like some regulation in place for this. I think we're moving faster than regulation is in a lot of areas. So I guess maybe a little bit of thoughts from you about where you think your sector is with regulation and what you'd perhaps like to see, and maybe some thoughts around whether you think that's in the same place as others or not in terms of sectors.
I can jump in first. I'm absolutely massive fan of regulation, formerly Politico as well. So the cement industry, the introduction of carbon taxing is going to be existential. They are exempt from carbon taxing at the moment, but they know it's coming. And this is one of the big drivers for them to be adopting technologies like ours. One of the interesting things that we've discovered more recently is the best available techniques don't include digitalization and process optimization or software solutions at the moment. I think they were last updated in 2013. So that we're part of a dialogue that's going to update those. And it's back to the point I made earlier about the avoidable emissions. There are going to be solutions like CCUS, and that is going to be a key response to things like carbon taxing. But there are definitely steps on that journey that could be regulated and could drive that adoption. I think in terms of an absence of regulation at the moment would be around digitalization strategies and best use of data and having like sort of common frameworks which would enable us to work with different cement plants, but also across sectors. We are focusing on pyro processing, so steel, glass, ceramics. There are a lot of cross learnings to be had from these industries, and how that data is held and stored and made available would be a key thing to unlock the decarbonisation challenge.
Okay, I can go next. Yeah, I think regulation in the built environment there's a lot of history, and there's very much a tradition of designing for compliance in the built environment. So everybody knows if you put an extension on your house, you've got to comply with building regulations. But there's no tradition of design for, so you design for compliance, you build for compliance, but what you actually need to be doing is design for performance and build for performance and monitoring that performance. And I think AI is going to be needed to actually monitor going forwards and actually demonstrate that your building is performing and performing to the metrics. And regulation would really help with that if we actually demanded that our buildings not only were designed to be zero carbon, but actually were demonstrated to be performing at a zero carbon level. And I think that's going to be really important going forwards.
Okay, I guess the within the agricultural sector, I mean, obviously it's, you know, it's not a controlled environment, it's an open environment. And so lots of sensor technologies out there now pulling in the data. I was at a conference just some weeks back with 50% of the attendees being farmers, extremely concerned about data sovereignty. They feel like they should own the data that's coming off the sensors. They don't want larger corporations to be able to leverage this because they don't see regulation. They don't understand how the data turns into knowledge and what sort of controls they have in there, or what controls will exist to stop that data being used in ways that they don't want. So.
There's some quote that I can't remember, something about data is the new oil, or maybe we're not quite there, but nearly there. With Open Climate Fix, we would love some regulation that if you have some solar panels, if you have an EV, if you have a heat pump, you have to register it somewhere, and that becomes public and everyone can start using this data. That isn't the case at the moment. So we would love to see that regulation.
Maybe thinking a little bit around. I'm sort of on or off, I don't know. People probably hear me. So I think maybe thinking a little bit around the international aspect on this as well. I mean, I've been traveling a lot this year, visiting places like the developing South, where that's going to be really important for supply chains. In China, where your machine learning AI will need to conform to communist speak learnings. And I was in the US the other day in Texas, and a representative informed me that they're looking to make sure that AI can't be woke. I'm not entirely certain how I program that, but you know, this is each country to their own. So we're going to see some very different abilities. This means that if you want to sell your product in different places, it will need to be trained differently. But also if you want to connect to supply chain. So perhaps some thoughts around that international aspect, because I think it's something that's being lost in conversation, certainly in the UK to me.
I think this is a relevant comment here, and I guess it comes also back to the adoption issue. You know, we really care about sentiment. If you are Coca-Cola and you're just launching a new campaign, you want to know what people think of your product. You'll go to Twitter, you'll try and use the natural language processing technologies, large language models to gather sentiment about whether your product is going to be successful or not. We need this for farms. We need to know whether farmers are going to adopt the new land management strategies that we want to implement, right? So large language models, you know, it's the exciting new end of AI, but it can be deployed in ways that will help us with the adoption issue.
So our clients are global. There are about 3,800 cement plants globally, of which half of them are in China. And as a young company, we are not even touching that because of that challenge, right? So as we're setting out, we've been focusing on Europe and sort of California because of the regulatory environment and how green it is. So that is a driver as an early startup to be able to go to market and know where to focus. The advantage of our technology is it also does save the company's costs. So there, back to the point about the driver earlier that Sam made. But but it is a challenge. But yeah, I guess I don't think there will be an international framework. We're going to phase away from fossil fuels. One of the challenges we'd be having is the increasing use of alternative fuels. I think in the UK it's about 43% use of alternative fuels in cement production. We want to be pushing that up to 70%. And we're seeing the variation of that globally. So it's quite regional, and what the motivations are for them to be adopting our technologies vary hugely, whether it's carbon regulation or strict costs. So it's a bit ambiguous really, and we work with each of our plants individually at the moment.
Energy's international. It's not just the UK that has having these problems. Our solutions are all open source. We're trying to release lots of data, so open data. So hopefully other countries and other people can benefit from that. I'll shout out to Patrick from UKPN, who are trying to also just release lots of data, and yeah, thanks.
Yeah, I think that's brilliant. Getting access to data from different types of similar buildings for us is really, really helpful. Actually, in the UK, we looking across internationally, every country is different. Every country has different design rules for their buildings. Every country has different use patterns for their buildings and different climates. So it's hard to be, do the same thing across all countries. But actually, what I was talking earlier about design for performance, in the UK, we're starting to adopt a system called Neighbours, which was actually originally an Australian system, which is designed for performance. It's exactly that. I know, and we're adopting their rules, and it's starting to grow in the non-domestic sector. And actually, that's a really positive development. So learning from abroad is really important.
I guess that brings us nicely probably onto skills and some thoughts around that. I think, yeah, it's a big issue for a lot of sectors for a long period of time, but specifically in AI. So I guess thinking a little bit around, do you think that the skill sets or do we have people with the skill sets necessary for the implementation of AI for decarbonisation in your sectors? And a little bit around, if we don't, what we think needs to change to allow us to get to that place where we have the right amount of people.
Okay, so I've just put out 4 job ads for scientists to work on a digital twin project, again, for optimizing the decarbonisation on farms in Devon. Very challenging. Our best candidates all come from overseas: New Zealand, US, China, Italy, etc. It's very difficult to get the appropriately skilled people for our sector. I mean, I think if we slightly change the title of the job ad to machine learning engineer, we'll get more applicants than we want, right? But for the sector where we're actually applying the technology for decarbonisation in farming, there are very few people that have those skills. So yes, we could teach people once they come in the door and say, okay, you're a machine learning engineer, come learn about agriculture and why we're doing this. Yeah, I guess there's an aspect to that, but they really don't have the skill sets, the full skill sets and understandings that we want. And that's slowing us down. So yes, we have significant challenges in recruitment.
We see lots, yeah, as you said, we get lots of ML engineers. That's much easier to recruit for. We struggle to hire software engineers. So that's my little insight into that.
I mean, the skills challenges is on both sides for us. The type of AI we're doing using deep reinforcement learning, there are not many people who are really focusing on that particular branch of AI. So there's a scarcity there, but also we're competing with Meta and Google, who can just afford salaries that we simply can't as a young startup. So we are really, really lucky to be able to attract people who do want to apply their unique expertise to the climate problem. And back to yay for woke, they genuinely are giving up a significant amount of their salaries that they could be commanding. But it also makes recruitment really challenging. Certainly, as setting up as an AI company, the upfront costs of any AI development are huge. So we've gone out for investment funding, we've been very successful, but it's not like a software product that you can sort of get out to market very quickly. We are building it and testing it, but also we need to be having that runway to be able to attract that talent, develop that talent, and develop our product as well. So there's a dual challenge with that as well. So we're not able to even expand the team as large as we'd like at this stage because of funding, even if we could find the talent. The other side of it is the user side, the customers that we're working with. We're seeing an increasing appearance of digitalization leads in cement production world. And I think there has been a real shift in attitudes to artificial intelligence more generally, certainly sort of an inevitability about its coming. And a better understanding, I think, partly driven by ChatGPT and the noise that we've heard over the last year. But there's certainly an upskilling from the cement producer side, understanding how that data can be used and how our solutions actually operate in that environment as well. So there's a skills gap on both sides.
Yeah, I also don't think it's just big companies like DeepMind overpaying or paying a lot. You know, one of my PhD students, 2 years out in the maritime industry, earns more than a professor already. So I think it's going to be all companies where those wages are going to go up, and it will cause a lot of issues.
Yeah, I was about to say that you should try academia if you but no, more seriously, I think, yeah, there aren't enough software engineers, but I mean, this is my own personal opinion. I've got teenage children and they're great coders, but they hated computer science at school. They hated the GCSE syllabus. They hated the A-level syllabus. And I'm looking at our sort of young PhD students. They've got brilliant coding skills, but that's almost despite what they learnt in school. They've picked them up on their own. So we're not giving kids the skills earlier on enough to actually be able to pick that up going through. And I think the challenge is, you know, a real education problem at a younger age. And actually, it's education of the teachers as well, because the reason, you know, they didn't enjoy it in school because the teachers weren't equipped with the skills that they needed. And it's such a fast moving, arena that the teachers need to have the skills so they can pass them on to the kids, and the kids will just pick it up, you know, like that. They're far better coders than I am. So that's where in my opinion, that's where
I think that's a really interesting point. And also because what we're doing has never been done before. Finding someone who's got experience of working in a cement plant and is a deep reinforcement expert, it's new, so they tend to be quite young, but there's skill sets we haven't tested them yet. So
yeah, I would add to that, yeah, that really AI is such a broad area, and you know, we all talk about machine learning, but you've got all sorts of planning, all sorts of logics in there. It's very difficult to teach to younger people. These are sort of what you learn at graduate school in computer science at the moment. They rarely feature even in undergrad computer science curriculum as it currently stands traditionally. So, you know, yeah, are we teaching people early enough? Are the topics suitable? Are they taught in the right way? I mean, I've just spent the last 15 years as a teaching prof in computer science in Canada. So I recognize some of these challenges, but there you go.
Cool. And I'll do my final question before we open things up to the audience. So make sure you are ready with some good questions. I guess a nice way to finish the sort of like stop questions is like, what's one thing that's like one tech that's inspiring you in your sector right now? What are you really excited around? What do you think is going to make a big difference?
So I'm going to pitch in for hybrid process-based models and machine learning models together. Process-based models are, you know, domain specific, and often they don't perform well at the extremes that when you want them to perform. So the hybrids of the process-based models generate simulation data, and then the machine learning models can come along and leverage that simulated data and build an enhanced, more powerful simulation. I mean, you know, we're talking about trying to build things like the weather forecast for farming. So that's what is going to excite me: the hybrid models, machine learning, and process-based models together.
We're speaking to Google about GraphCast, and that's very exciting. So that's going to be a very quick weather forecast that's very accurate. So I'm excited by that.
I would have to say cloud-based AI-powered process optimization for industrial decarbonisation, because that's exactly what we do. So.
Which is very exciting. And I'd probably have to say, well, I'm really excited by digital twinning and the idea of taking what we've learnt for the underground farm, but actually what we're developing at the Turing is a platform for an open access platform for digital twinning. And the idea for me that But one day you'll have a digital twin in every house and it'll just sit there in the background and will run your house and optimize it, how it runs and keep your energy costs to a minimum. And it'll be really easy for everybody to run their buildings really efficiently. That's what really excites me.
I got my mic taken away for being boring, I think. So can we questions for the audience? Oh, already a volunteer. Should we start down here in the middle? I think this man here looked very keen.
Yes, I'm Stefano Bonfa. I'm from Oxford Sustainable Development Enterprise. And my consideration is, do you don't think you put too much emphasis on AI while AI is filled by data? So because the European Union is moving, for example, space data is a new concept of data in the context of space. Building digital twinning or any application, if you do not have this framework of data, how you get the data, how you manage data, how you process with higher computing technology in order to reach the objective, you don't reach the objectives. I mean, this is my consideration. Thank you.
I would agree with you that it's a very complex technology stack, many different components, getting the data, getting integrated, analyzing the data appropriately, building simulations, again, arriving at a digital twin. It is hugely complex. You know, I think we're very aspirational. I know there are lots of people using these words. I guess that's the other piece here. We say AI and we mean so many different things, right? We say decarbonization and we've already got a whole panel of different opinions, right? It is in essence too broad. See, my response to the last question was process-based models with machine learning, right? It wasn't AI. You know, it's really, we got to tighten up on the way we use the language. I mean, AI is an umbrella term, digital twins is an umbrella term. You know, they're nice to bring everybody under the same tent, but realistic, we need to get back focused on what we mean by and what technologies are required to actually deliver the capabilities that we're after. And interoperability, I've heard the word today, hugely important. And that's all about data standards and making sure we agree and stick to these standards that we apply to ourselves. I could go on and I think I should stop, but I'll let others.
I'll just jump in quick. Yeah, AI can mean lots of different things, as you say. We spend 90% doing data engineering, so you can call that AI if you want. You can call it something else, but we spend a lot of time doing that.
And I just wanted to jump in. So we're a mission-driven company. We want to reduce industrial carbon emissions on the gigaton scale. We're not going to do that with just AI. I think we've got a couple of our white papers on our stand outside, but it's we wrote a paper called 3 Technologies to Reduce Carbon Emissions, Climate Change. And we're focusing on the technologies that are out there today that could be that are scalable, that could reduce carbon emissions in cement production by up to 82% between now and 2030. So these are not just AI is part of that journey. It's part of a toolkit of solutions, but it's not the answer to everything. So I think we need to be really careful about understanding how they work in concert with our solutions.
Yeah, and I'll just chip in very quickly, actually, that for a lot of buildings, we already have a huge amount of data. And the question is, what can you actually do with that data? And a lot of it just gets either stored or just gets lost. And yeah, using a lot of what we do is data analysis, and building smarter tools to do that data analysis and making it easier for ourselves is to a certain extent what we mean by AI. So as you know, AI is a different thing to everybody. But
I was just going to say as well, within engineering, certainly it's well documented that UK is behind certainly France and Germany on databasing and stuff. So while there's a big focus on the machine learning tools, we don't have the infrastructure for this, and we know that, and it is concerning that there isn't more of an emphasis on this, both at university education level and in terms of the sort of work that we're doing. In fact, most of the work that we end up doing in sort of the impact side of things is going into companies and installing data pipelines and helping them do that. We don't normally get to the machine learning part in a project because they don't have that infrastructure to allow them to implement those things at the moment. And that is a big deal, I think. And that's especially hard in very large multinational companies. You can do it in a small company quite quickly, but really engaging with a large multinational on that front is a very hard thing to do.
Hi, I'm Mark Enser. I'm a previous head of the National Digital Twin Programme. So that was all about this idea of an ecosystem of connected digital twins, so the federation thing. And in many ways, my question is a little bit similar to the previous one. But I have to say, it's so lovely to hear you talk about AI and digital twins together and this whole idea of kind of cyber-physical infrastructure that's connected. But in that, it feels like some kind of data sharing infrastructure is important, some kind of shared approach, so that this fuel for everything you're talking about can be shared between these various different systems. So what I'd like to ask is, do you see that as actually being an important enabler? And if it is, how do we make it happen?
So on this particular issue, in Devon, we have this experimental farm, or series of 4 experimental farms. We've collected 80 million data points over the last 13 years, and we want to build farm digital twins. We've also made the data available and free for download to the public, so others can join us in this journey. Downloads of this data are few, in part because if you have this large amount of data, you download it, all of a sudden you have to unpack it and understand what all the fields mean. Maybe the metadata isn't very good, so we need better ontologies to maybe describe the data itself, right? Now we're deploying an API layer to make sure that people can query only specific subsets of that larger data set. And we're also want to make sure we have semantic APIs, so people can actually, not just technical people, but scientists can also go and basically pull out segments of data that they care about. So ultimately, yes, it's extremely important to ensure that the data gets out there to as broad a range of stakeholders as possible. Yes, it's a barrier. Yes, we're trying to solve this as actually as a first step. And I guess the key really also then is to ensure that we can enable agile integration of these data sets with process-based models or data-driven models that are needed. So that is another key component there. For designing a plethora of digital twins, because it's never just one, it's many little ones, we do need the semantics, as I've said. We also need to have a platform where we understand which models are available for which type of analyses and which data sets are available. So we almost need a framework, a benchmark for modelers, right? Because in digital twinning, really, you're supporting the modelers to come along to build solutions so that somebody else can ask the what if questions from those simulations. So ultimately, we need a workbench for modelers.
I'll just give an example of where we've seen it being successful. It's not just about releasing the data, it's also about releasing tools and making it, as you say, releasing an API or other things that just lowers that barrier for users to use the data and use it however they want. Yeah.
Okay, I'll jump in. Yeah, I mean, yes, the answer to the first question is yes, definitely. That's quick. But I think one of the underpinning sort of ethos at the Alan Turing Institute is all of the software developed is open source. It's all available on GitHub. People can contribute and develop that. And I think the fact that people can see it and understand the data frameworks that need to go into the tools that are developed, I mean, that helps to make it open so people can see it and understand it. Semantics is what we're talking about, but perhaps there's a role for regulation or a role for systems to be developed here, frameworks to be developed that people adhere to, so that people can use other people's models easily. And I think we're talking about the same thing. I think is some kind of toolkit, modeler's toolkit.
I was going to From my limited understanding, from the success of examples like the energy sector, that sort of digitalization task force for industrial processes would be really helpful to apply those lessons, to have that as the data standards frameworks. I think it could be there's a lot to be learned from the energy sector, I think.
Yeah, I believe there is an information management framework that's been developed for environmental digital twins coming out of somewhere in, I think, CEH. Gordon Blair worked on that, I believe.
Hi, yeah, Nathan Hertzfield from Sarah Sharples' division within DFT. I'm head of innovation. So I've been in many meetings this week, meeting with people from across Whitehall, and I can't tell you the amount of times I've heard about the issues with recruitment, with skill shortages, with capability building. I used to be a teacher myself, and one of the things I first told my year sevens was, I'm training you for a job that doesn't exist. It's really hard to do that. It was easier back when I used to teach. It's much harder now. So this is kind of building on that question of capability building. Imagine you're sat in front of the computer science lead within the DFE, and he says to you, we can change two things about the computer science curriculum, one for GCSE and one for A-level. What would you recommend?
So there's a book called Introduction to Artificial Intelligence by Peter Norvig, who's chief scientist at Google. In many of these panels and discussions that I have, I show a slide of the table of contents of his book. And those people who have gone through a proper AI training in a good university will be familiar with the book. I think, of course, when you get very technical, you know, it comes back to your software engineering capabilities. I think the high-level concepts, you know, things like first-order logic, knowledge representation, reasoning, right, links back to logic, philosophy. I think there's a role for that to make sure people are open, or young students are open to these concepts at an early stage. It will help them later on go beyond syntactic coding and really think about how systems can, you know, like I said, do reasoning. AI is about being able to do things beyond the capabilities of the human brain. Reasoning is a key component of that. I still don't see much reasoning inside the typical machine learning stack. You need a level of formal semantic as well. So my comment is going to be bring in a bit more of the concepts of AI at the A level.
I'll probably say something a little different. We find it, the candidates we have that have experience in projects they've done, whether it's personal or in the industry, it's just super valuable. So I guess I don't know anything about the GCSE or A-level computer science curriculum, but I'd encourage students to get involved with, there's like Kaggle competitions or open source projects, and if that could somehow be involved, that would be super handy.
Experience. This is what they tell me. So the problem with the GCSE curriculum was there's too much about how computers work and not enough coding. So I would cut that bit down and put more coding in and make sure it's coding with Python or something that's openly accessible so they can go home and do it if they want to. They're not reliant on software they can only access at school. So I would make that. And then I would develop that further at A-level and actually put more complex, maybe object-oriented programming in, but it has to be accessible to kids who haven't done GCSE. So it has to be a sort of a pathway through. But I would emphasize sort of Python and coding languages that are freely accessible and freely available to download, or JavaScript, you know, things that they can access at home and they can actually create something without needing anything that they have to be at school to do.
Probably just add statistics. We don't seem to put enough emphasis on statistics in our education process. So it seems a bit of a bad road to go down in maths when I was doing A levels, so maybe it's changed, but I think stats is important. And I think more of an emphasis on soft skills over just knowledge-based retention. You know, the jobs that, like you say, are going to be so different, we don't even know what tech they're going to be using. So actually emphasizing how you learn to learn yourself, how you utilize the knowledge that you've got, speaking publicly, like all these sorts of things, I think are probably more important, and I want to innovate and learn through later life. Yeah, I think next.
Sorry, I've got the next question. Jessica Rushworth, I'm the Chief Strategy and Policy Officer at Digital Catapult. So this is more of a controversial point, I'm going to say, on skills. So I've never had any problem hiring people, and I hire from multiple different. So I keep a very open mind and think about what can we train people up in? Because sometimes I think people are expecting a lot from schools and universities to have trained them up in application areas. So what do you think you could do more in your organizations to train people up on, and what would it take to enable you to do that?
What would it take?
So what would it take? So in some of your examples, so you're looking for people who've maybe got the technical skills, but they haven't got the application skills. So they might know about machine learning or AI, but they don't know about your particular industry. Or it might be the other way around, where they know about your industry, but they don't know about AI. So what would it take from government or policymakers or interventions for you to be able to train people up more from the industry side?
Yeah, I guess it often depends on which direction you're going in, whether you're training biologists in coding or whether you're taking a computer scientist and asking them to learn about agriculture. The latter is much easier, I would argue. And so really, if you're going to choose who to hire, you probably hire the computer scientist and then put them inside the environment, give them exposure to the experts inside the environment. But I'd also make sure that they attend a whole series of not just conferences, but go away and do some self-learning on some of the key topics that we would advocate from our scientists. So for example, maybe take the computer scientist, software engineer, send them off to a conference on carbon sequestration, and also give them some key articles and get them to develop the baseline knowledge, and just sit in all the meetings that we have around, our ADViCE is the most widely used carbon sequestration model. We would have, those computer scientists in the room at the same time.
My cousins are all roofers, and they learn their skills essentially through apprenticeships. So I'd encourage companies to take on interns, take on people like that, give people real world experience.
I was going to say exactly the same thing, actually. I think there's a lot to be said for apprenticeships, across a lot of fields, and and learning on the job, and learning when you've got some skills, actually being able to learn those with application is definitely. I mean, how many of us, when we start coding something, the first thing we do when we don't know how to do something, we just Google how to do or put it into ChatGPT, write this bit of code for me, and learning how to get those skills. But really, if you're going to learn to code, you need an application to code for. You need to actually something you're applying it for. You need a reason to make it work. And I think apprenticeships have a huge potential to actually for people to develop the skills that they need.
That, and I think just my perspective as a startup, actually a lot of our staff is the first job out of university. My co-founder, Professor Aidan O'Sullivan's Associate Professor for AI and Energy Systems at UCL, which is a rich resource for our recruitment. And we're really good at internally. We're an interdisciplinary team. We have lunch and learns. We have as much as we can do with limited resources. But we've been approached quite a lot about having internships, and this is something that we would really like to be able to do. But it's resource intensive. You've got to give these people a good experience. We're just not in a position where we can fund that at this stage. So not just in terms of financials, but also in the time resource to give them that experience. So we'd need to be bigger. We'd need more money. So that, I mean, we'd love to do that, and we know that is the route that we'll need to take, but we'll just need to have more money at that point.
Hi, Simon Hart from Innovate UK. I've got the pleasure of looking after cyber physical and digital twins at Innovate, which is challenging. We've obviously through all the work that's been done recently around cyber physical and identifying some of the barriers to market uptake, to adoption. A lot of it has come back to data and availability of data, data interoperability, data security. One of the things that has worked well in the past is to get all the big government departments who buy a lot of stuff like infrastructure and get them to work together on standardizing data. And it worked, my old life in the construction sector worked well with sort of BIM and other things like that and getting that through. I've got a meeting in January with the IPA, Infrastructure and Projects Authority, which is part of Treasury, to try and push some of this. What do you want me to say about data?
So I'm gonna mention a word here that's been used a lot. I happen to know the two people who invented this, fair data. Fair data is a set of core principles underpinning how we should provision data: findable, accessible, interoperable, reusable. This is very challenging. Anybody who says that they've got a perfect fair data system, I would go back and double check, right? Because, and I know this from speaking with people who work at Stanford and Harvard, people in Europe and here. Data standardization is hugely challenging. We've had years and years of semantic web where we wanted to articulate standards from the W3C that should be adopted. We only adopted half of it. And even now we've migrated away from RDF to GeoJ to the JSON and other formats. It's a difficult one, right? It's not a nice answer. But I guess it's part of the piece is not just saying, here's a standard. It's getting the adoption again, evangelizing, building the community around the standard, giving more examples of how people have leveraged that standard. We need exemplars. If you look at NERC, the funding agency, has just put out the Twine, the NERC Twine call. This is about building exemplars of digital twins so that people can learn how to do it, right? It's a really good opportunity, and I'm really looking forward to seeing what comes out of who gets funded and what they actually build. But I think that's good investment.
Yeah, just leaning on Chris's point, would be an advocate of the FAIR principles as well. And I think we'd want to ask for industry to publish their digitalization for decarbonisation strategies, to have that out there and to be able to compare it. I think when we look at some of the data, it's below the bottom line. It's just kept in different ways. ESG data, just how are they reporting? How are they capturing this information? So beyond the industrial data itself, but also on their emissions as well. So yeah, much more transparency.
Yeah, I would echo what's been said. I think transparency. I mean, I think the key one of the key issues is interoperability of smart systems, and I think anything that can help you to get to a situation where you can get different systems to talk to each other, or to at least be able to bring all that data into a central point easily and make that an easy thing to do. I think that's got to be a huge step forward.
I'll just give an example from the energy storage world where all these huge batteries had weird and wonderful ways to connect to them. And that will be the same for residential, that'll be the same for EVs, that's the same for PVs. So it comes down to standardization and pushing for that.
Well, I think that's all we've got time for. So thank you very much, audience, for asking lots of questions. If you didn't get a chance to ask your question, I'm sorry, but we do have 30 minutes of networking, so everyone will be around for you to ask lots of things. So I hope you enjoy the rest of the day. And I think we've got final comments from Vicky.
Yeah, I really hope that panel has really brought to life some of the really sort of exciting on the ground work happening in this space, but also some of the challenges that hopefully we can all come together to solve some key takeaways there. We need to ensure that we're developing pro-innovation regulations and making sure that we're continuing to encourage innovation in this space, but also ensuring that the regulation supports that. Skills is constantly, a really important factor in how we match the skill sets required for innovation. But really, I think one of the exciting things about this work is really bringing to life those AI for decarbonisation use cases. I think we've heard it from the panel, really having those sort of core examples of how this work is being done well and secure and responsibly is really important. And so on that note, I won't keep everyone too long. It's worth saying that we have, as Paul mentioned, there's a Stream 2 competition for AI for decarbonisation funded by DESNZ, and we've got 4 of the companies who have been successful in that funding outside to talk more about these use cases and really bring these solutions to life. So please do stick around for some nibbles and talk to the companies while they're here. But it's been a real pleasure to have everyone in the room and over 200 people online, I believe. So really thank you so much for being here, and we want to keep you all involved in the programme. So as you can see, more codes, more things to download. But in the networking area, as I've mentioned, we've got Carbon Ray, H2Go, List.io, and Open Climate Fix. They're all working across different sectors. They're all building different solutions with AI. So please do stick around and network with them. This project is all about convening and collaboration. So if you want to get in touch with us, I'm looking at Alice and hoping that this is the right email address, but it's advice@turing.ac.uk. So if you want to get in touch with us and tell us more about what you're up to, please do. We'll be convening a series, as David mentioned, of workshops and webinars in the new year. So this is all going into 2024. But in the meantime, I hope you all have wonderful Christmas breaks. Please use your decarbonisation cards and spend many hours playing with them for Christmas this year. But really, on behalf of Digital Catapult, Energy Systems Catapult, and the Alan Turing Institute, a huge thank you for being with us today and for DESNZ for funding the project. We look forward to the next steps. Thank you very much.